Hello everyone. Yeah, we met just a couple of minutes ago, and then I have a very small and very funny lecture, and then I introduce what kind of research we are doing in our institute, and also what I did before coming this institute. And you guys very interesting about traditional medicine, right? So, and for my background is botany, plant science, and usually the material made by the material is plant. For herbal medicine is by the plant. So plant is how important for the material of herbal medicine. So before coming to my lecture, I want to know you guys which country from. So would you please just quickly. So Afghanistan, Bangladesh, and you can push the button and then just quickly say which come from. Yeah.
Good morning, Dr. Muhammad Bashir Qureshi from Afghanistan.
Assalamualaikum, Dr. Muhammad Hussain, Bangladesh.
Good morning, I am Dr. Hassan Imam from Bangladesh.
Good morning, here is a combo from
Morning, Laura Lee, Cameroon.
Quebec, whatever, Ghana.
My name is Sajna. I'm from Bangladesh. My name is Roro from Zimbabwe.
Good morning, my name is Soka Samuel from Zimbabwe.
Good morning, I am Kwaya Jamil Kapome from Uganda.
Richard Komakech, Uganda.
Grace Nambete, Uganda. I'm a chemist, but I also did botany, and I love botany.
I'm going Dr. Suleika from Sri Lanka, and I did exam.
Thank you for your introducing yourself, and also we have three or four guests. May I ask a favor, because they are graduate student, we have a UST program, and then I'm the lecturer for the class, and then they may have a chance to look at you guys and what we are doing. So there's three beautiful students and another photographer. Okay, now it's enough to begin. All right. I don't know you guys' background. Do you know what is meaning of propagation? Right. So my background is biomass, increasing the biomass, using the biotechnology or tea culture and medicinal part. And also, before coming to this room, we just see the identification using the microscopy and chemical fingerprinting and DNA analysis. So this is me, and today I want to introduce some worldwide issue, and also the propagation, and then the past project, what I did, and what kind of project I'm doing. And then internationally, we have an issue about ISO, International Standard Organization. And I'm very interested about some of our individual herbal medicine. And also some available plan in Korea, and how we have to manage for herbal medicine and propagation. That is the lecture. So, have you heard about K-pop? K-pop. This is kind of a teenager word. K means Korea, pop is popular music. So if you see the website and Korean pop or K-pop or Psy, something like that, you can see what is K-pop. And Pastor, our president of this institute, he created the word K-pop, Korean pop, like that. So we want to make a booming or try to make a famous for the local horror for the whole country. So we have a new word, K-pop, K-pop. Okay. I just introduced to our country. Unfortunately, we separate North and South now. You guys here is Daejeon. And this is a flower, the Rose of Sharon. This is our national flower. Yeah, national flower. So we have 200 different cultivar already. Cultivar. So original plant is the scientific name is hibiscus citrus, but variety is more than 200. And this is a website, our institute, there's English version. And the handout, you can see the URL, so you can visit anytime. And this is a whole issue. I'm not sure this is how much related to our lecture. For me, as a scientist, and also I'm interested in environment. Now, the temperature is increasing a lot and getting hotter and hotter. So how we control the plant cultivation and propagation. So we have to think about some regulation. And as you see some figure from a couple hundreds ago to current, the global temperature is still increasing. And the ocean and land, the base station is the ocean water level is increasing. That means we will have a lot of problems. For example, this is one of the plant, Bacillus tumbogi, and currently in the ocean, the beach area and the coast area, they are growing. Later on, the availability is a change and limitation. And then later on, how can we control this cultivation and propagation? See, some of the herbal medicine, we also doing kind of a plant list. So citrus and ginseng, ginkgo, and venia, and Orostexis japonica. This kind of plant is usually useful in herbal medicine in Korea. Maybe some of the genus level in your country may growing. So we call original plant or origin plant for herbal medicine. So we don't know this herbal medicine come from. So we have to know the exact material. As I said, morphologically, this is a medicinal name, Pinelia tumber. Tumber means the root, small root. And this is a plant, is a ripe plant. But in Korea, Korean pharmacopoeia, this is not right medicine. Only this one is the right one. So we make some protocol, morphologically, how they look like. So we have some list how we distinguish. And also the other one is this whole plant But this one is only root medicine. Actually, this tumor is the medicine, traditional medicine. So as you see, the shape and color is different. So we have a protocol. And the other one is a DNA marker. Plant had a DNA, they have a genomic DNA, they have a ATGC sequence. And we make the ITS region using PCR and amplify specific region. And this is one of the ways how to identify right plant. And the other one is a chemical analysis. This is a LC, the liquid chromatography, and so they have a profiling. Some of the peak doesn't have, not exist. So this is kind of a chemical marker. And also we have a profiling group. So it's some of the statistical analysis. So at least we have a morphological analysis method and genetical marker, DNA marker, and third is a chemical marker. So using three methods, we can identify right medicine. From China, we usually import from China. They have many material and they mix together commercially. We don't know that they are right one or not. So DNA barcoding technique, this is a DNA came from chromosomal DNA and mitochondria and nucleus. Usually from nucleus, ITS is commonly used, but sometimes it's difficult to distinguish. We can protoplast from mitochondria we can use. This is some of our way, and we make some DNA back library, and we can get the DNA sequence and try to find some hybridization and amplify specific region. So usually PCR and sudden or enzyme digestion we can use. So continually DNA barcoding. So some of scientists told us, why are you using the DNA analysis? And also, if we just using the DNA analysis, it's difficult, but we have a combination. Plant background first, and genetic and chemical. So now I'm talking about DNA barcoding. So in the field, our botanical people go to the field and collection, right plant. We have a 3 or 4 different plant area scientists working together, so we easily collect the DNA sample. And also we sequencing and analyzing, or sometimes we compare RAPD polymer. So right now I'm talking about the current project is based on the propagation. So some of root or whole plant and some plastic, the propagation. So now I'm doing some development of basic technique for domestic cultivation of herbal medicine resources. So in Korea we have this plant. Have you heard Palopia multiflora? I'm not sure in your country you have this. This is a root. It's not a thin root like a potato or sweet potato looks like. This is a 3 years old root from this plant. In Donghibogan, written by Hejun, our ancient also using this for human disease. And also the making color black. And different family, different genus plant is in Korea. We have a lot of plants is mixed together. So we definitely find the DNA marker. And then we have two methods. One is based on seed. The other one is, I'm going to tell you later, from seed. And this is physical, the X-ray analysis. In the seed, they have an embryo. So we find the right embryo or healthy embryo, and then detection, and only good the seed selection. That means we try to increasing the high percentage of germination. And this is multiple therapy, thermo germination, kind of PCR technique from 18 degree to 35 degree. We can make the temperature. This line is one temperature, like 18, 19, 20, 21, like that. So that means we can find optimize which temperature will be good for the germination. And also we move to the field, sometime greenhouse system. This whole purpose is healthy or very elite plant, and we can increasing the production level percentage, and also safely and also stably we can production a lot of biomass. This is a seed-based. This is seed-based propagation. Now I'm talking about tissue culture level. Why I'm doing tissue culture? Because the virus-free plant production. Because for final product, we're going to use the herbal medicine. That means we have to make no bacteria, no fungi, no disease. Very good or elite plant we need. So this is one of the risks we're doing, and also identification or distinguishing our material is right one or not. And also in the short tour in herbarium, we see that sometimes we use whole plant or sometimes stem or bark, sometimes also using the root. So try to find some germplasm from stem or leaf or root. And this is a propagation material. So sometimes root and seed and leaf, root stem, and then rapidly we producing this explant and accumulation in the soil and pineapple. In the field system, we have a greenhouse. Now, 2 years later from now, we're going to have some herbal medicine resources center in Jeonnam province, which is 2 hours from here. In Daejeon, we don't have any field research yet, but 2 years later, we're going to have some kind of this field. Now I'm really talking about single herbal medicine for international standard organization. Is there any person know about ISO? No member of ISO in your country? Last year in China, and this last year in Japan, this year China, we have a big meeting. ISO TC249. That is the name of traditional medicine. ISO TC249. So we have a meeting, and they have a working group 1, 2, 3, 4. Working group 1 is raw material of traditional medicine. Working group 2 is raw material and final product and processing. Working group 3 is the medicinal medical process, and 4 also. So my part is working group 1 and 2. Yeah, device. Are you a member of the ISO? Okay. You're just interested about ISO program. So I just came to China this year for ISO meeting. So I make a new proposal about 2 items. So I'm going to introduce what kind of item I'm interested in, why we need for ISO standardization. So my concept is like that. Traditional medicine is here. We have so many traditional medicine. I'm talking about plant-based or plant. That's back to general. For single medicine is very individual. We have 2,000, 3,000. For ISO member, they ask me, why you use the single item? So you making ISO rule or ISO standardization one by one? They ask me, but I said no. I have a priority. Some of item only we choose, and then we go further. So in ginseng, already done in Korea, and red ginseng, and also America and European and China, they have ginseng a lot. So ginseng is no problem. Right now everybody agree because ginseng market is huge. The platycodon root. Do you know platycodon? Okay, I show you the picture. Looks like ginseng. It's not ginseng. It's platycodon. This one. Platycodon. No. So anyway, so in Asia, platycodon, China, Japan, Korea, we have a formula, multiple formula. We have more than 100 and more than 20% of formula, they require this one. So that means how important it is. Actually, we also producing this one in the field a lot. But in China case, they have people is a lot, and they have a system is good. They are exporter case. Japan and Korea case is importer case. So for ISO regulation, we try to increasing the regulation because we have to import from China product. And we have, for our human, Korean people, human safety, we try to increase the requirement. But export case, they want to reduce the regulation and requirement because they want to sell a lot and easily. And we are fighting, actually. So this is the ISO situation. So we try to control packing system, storage, and pest management. But definitely depending on plant specific things. So, and then harvesting, raw material. This is raw material. Raw material and harvesting. That means actually this is talking about quality control because we thinking about our national safety. So praticodon is I already suggested this summer. Now this is processing now. Praticodon grandiflorum. This they looks like. So try to making an international quality standard. And then, as I said, international level. Some people want to import or export. They need to follow international level, like a ginseng bee. This is a summer market in the USA, $1 billion. From 2004 to current, the market is increasing. And also production area in Korea, so only South Korea. This is a hectare. It's increasing too. So in Japan, they have a traditional medicine in the market. They have so many different items in the Japan. And this is good for cold. So when the traditional medicine, it looks like this is a little bit, this kind of product from these two there. So another one is I'm interested in is a Astragalus membranalis. Have you heard? Where is the picture of the plant? I cannot see, but this is the same concept. I chose two items, and last one and this one. We need to make an international quality standard for Astragalus root because of the safety and quality. And Astragalus root case also, the market and production level is increasing too. So between export and import for international control is required. In ginseng case, everybody interested because that money is around. And in each country have a plant material, and maybe you guys want to export to other country. And how you guys suggest or explain this item is very important for international standardization. So you have to adjust this single item is important for international level. And now in China government, they submit more than 5 or 6 items every year because traditional medicine, the word definition of TCM, traditional Chinese medicine. In the ISO meeting, they also always suggest TCM, traditional Chinese medicine. But the other countries suggest just traditional medicine. In Korea, we call traditional Korean medicine. We buy. But last meeting, and they have a 12 country, they have voting, and raise your hand, and more than 50% agree TCM. Now is the word TCM, unfortunately. So in Korea, the funny thing is TCM. Now we call K, Korea, but long time ago which is C, Korea, C-O-R-E-N. So TCM means the traditional Korean medicine. So we make funny, but right now, international standard organization, they prove TCM. The terminology is approved. So do you guys know about NIH? NIH is the National Institute of Health in USA. They have a website and herbs and grains. So there are so many different plant material. Astragalus is here. that means this is a good item for international program. So in Pakistan, or they have this kind of institute. Pakistan, or Bangladesh, Mongolia. So now standard suggestion is example packing system, because during the packing system the harmful things a lot, and storage, and we have to think about the humidity and some store temperature. And from China to Korea, making the ship, a boat, or train, or airplane, we have to consider about environment transportation and also the pest control. The main problem is the sulfur. Sulfur purpose is bleaching. See, usually that's the yellow, brown, little bit white color, but people like very white color. So in China, they using the sulfur, try to increase the ppm of sulfur and making a bleaching, make it white. But for human health, the sulfur, the little amount of sulfur is okay, but certain amount of sulfur is very harmful for each person, or allergy, or the regulation. So in the international level, we are thinking about sulfur level. And export case, they reduced sulfur level, but import case, including the sulfur regulation, because the human safety. That's why we need an international standard for interesting the single item. So this is not only for single country benefit. Import case, maybe China, not China, the Korea and Japan, we have to control the quality product. But China case, export case, they making a different brand. Oh, this is ISO brand and certified item. That means they can get the money higher, and they can earn the money much more. And other case, we have to think about traditional medicine and safety and some improvement, credibility. So that's why I'm interested in standard. Could we increase the demand of market for traditional medicine? So maybe Bangladesh or India or Thailand, the warm country, maybe hot, warm country, they have this similar trend. Is that right? So natural paint, the pigment. In our ancient, they use the pigment from extraction of this plant. And the purpose is a decay resistant. That means it's a coating for wooden dish and ship and shield. And this is a tongue oil tree. This is all extraction from the fruit, yellow, orange color. And this is really sensitive for each person, allergy. Urucinol is the liquid type secretion from bark or stem and leaf sometimes. And this for the against to insect and decay, moisture, heat, and salt and resistant. Our ancient, long time ago, we used the extraction from this plant. And now I'm talking about some factory. Traditional medicine is important. I agree with that. But now market is increasing and so many things going on, and westernized market, the pharmaceutical market is increasing. How can we control? So we can follow some system too, the government. Our concept is thinking about from ancient text, like 동의보감, from text to future. So our slogan is from text to future. So Bangladesh, Mongolia, and other country people, you guys have an ancient book or protocol. Using that ancient material and using the current biotech or technique, and then we can go further. So this vaccine or cytokinin or antibody all from the plant, natural plant. So we can do this way using the herbal medicine. And now I'm talking about propagation, the herbal medicine in propagation. So this is a embryo, and this is a callus embryo, and this is plant, and this is a flask. This is the only root. So hairy root. So we're using some factory level bioreactor, and this kind of material and technique in the herbal medicine we can improve. Okay, this is a Korean traditional medicine and formula, and then you can boil like a traditional way using the biotech technique. That means we can do increasing the more production. That's my concept. So I just a little bit faster than I expect. So I can talk about some question and then I can explain. So is there any person have a question? I can answer.
Thank you for the presentation. My question is on use of bioreactors. I know of a certain company here in South Korea which is using bioreactors to propagate or to make, actually to do ginseng medicine using a stem cell technology. What are your comments on that in relation to the original ginseng? Is it superior? Is it inferior? What's your take on that?
Your question, okay, we have a ginseng that's traditionally cultivated in the field, right? And we have, on the other hand, we have a hairy root type ginseng using biotechnology like bioreactor, right? And production level, in the field case, we have to wait more than 3 years, because the time limit, and also during the cultivation for 3 years, we have a lot of problem, like in the soil, we try to using chemical killer for bacteria, fungi, and they adapt in the soil. That means the ginseng plant eat that chemical. That means human have to eat. And also the time and health and other things a lot. But biotech and using that material like this. And this is originally from original plant and virus free, no contamination. And then moved here. And this liquid media is all nutrition is good for human health, no problem. And then we move to this small bioreactor and only using the root, the saponin percentage, the content is a higher percentage in the root, not the stem or leaf. So we are talking about the root. And this case, we can optimize temperature and nutrition and everything. This stage, maybe 6 months is enough to same amount compared with the 3 years field growing. So, and also we analyzing the HPLC and then the profiling, how much they are similar, how much they including the saponin level. So we also detect. So we submit this result of content to government, and this is no problem comparing the pharmacological purpose.
Actually, my question specifically with ginseng, I tried to pose this question when we visited the factory. That I knew of another factory because they've been trying to promote their product in Uganda for cancer and HIV, but they use that new technology, mass produce, and it seems the product is good. But it's like they didn't want to hear about it. Is it competition? I mean, now for me, I need to know: is it inferior? You know, because when you look at the biotechnology, it's state of the art. Really, they use one stem cell and just mass produce. So, in your opinion, is it just competition?
Not a competition. Like okay, everybody have their own way. Like my father is a traditional breeder. I am a biotechnologist, and he has his way. I have my way. So I'm very open mind. Sometimes traditional way is good. Sometimes new technology is good. But I always have that kind of question whenever I have a presentation or I'm doing some research, or even doing the tissue culture. But if I doing some GMO, like genetically modified the organism, but I'm just to give up. But it's not GMO. It's not GMO. Just virus-free plant. So and also in Korean herbal medicine, we have a two system. Only making this root, and also we have a adaptation. This, see, this is not finished. It has to soil, making a whole plant. So if we finish this product, maybe some traditional breeder argue, but in Korean medicine, the concept from the soil have a lot of good benefit. From this environment to plant. So we have two ways, sometimes making some biomass in the flask, this culture level, and then we can taking out and then grinding, or we can use for raw material. But later on, we can go further, like a real plant, like field test. So from seed to this culture to this the time and but the healthy other limitation, we have a lot of benefit. That's why I'm doing this kind of research. So all materials same, all techniques same, but based on the adaptation or environmental issue, some of the step we can use biotech. I think that is a good option. Traditional plus current biotech, and we can go together for herbal medicine.
Just another one.
Yeah.
In relation to that biotech that you are doing, I know the one of isolating a stem cell is more advanced. What do you think about that one? Because would you also take that channel because it would even shortcut you more? Because you have the highest technology here. Are you already considering it?
You question is isolation of chemical?
No. It's not a chemical. A stem cell from campion, like that key master cell.
Yeah.
And then you really propagate it. Isn't it even higher technology than that one, which can even, for purposes of the economy, which can even accelerate your, are you also thinking about it?
Okay, for example, this is an embryo stem cell, and then so this is a kind of our stock, and then adding the plant hormone, the plant growth regulator like auxin or cytokinin, gibberellin, like that, we can produce plant, and then we cut this, and then multiply, and then move to this kind of things. So this is a kind of a bank. Gene project. Yes, please.
Thank you very much, Dr. Young,
Yes.
for your wonderful presentation.
Thank you.
I'm a botanist, and I would like to inquire something about the tissue culture, because I know that there are some plants which are propagated through seeds, and seeds normally come as a result of pollination, which involves leads to genetic variation in the plant. If you have a bank like that of those tissues, don't you think you will have limited, you will have tied down the future variations in those plants?
You're talking about
What I mean is, don't you think there will be stagnation now in as far as variations in those plants are concerned? Taking maybe you are going to use them maybe in the next 5, maybe 6 years. What will happen? Will that still be like of the same plant like those in the wild?
So, for the seed case, they have the Mendel genetic rule. They have a 1-to-1 or 2-to-1. But this tissue culture benefit is if you have this embryo or stem cell, you can multiply another one, and this genetically, this one is the same. And if whenever you multiply or subculture, genetically same. But only problem is optimization. We have a small flask optimization condition. We move to 2 liter. We move to maybe 1 ton, 10 ton. Each time they have a little variation for optimization culture, not a variation of a genetic plant.
In my country, the technology has not yet so much advanced, and the method of plant identification is mainly based on the morphological appearance of the plant. And of course, we are aware that that comes with a lot of errors, considering that plants from different regions
Yes.
might be the same species, but morphologically they may be what? Different. They may look different. And I think it is now time for us to move to the next level of maybe the chemical and the DNA analysis, and as far as identification is concerned.
Yeah.
And that is, I think, the basic right now to go because of the climatic conditions. The morphology of the plants are now different. You may pick the plant from the wild, which is quite now different from the one we have in the valley.
Yeah, that's correct.
And that makes it very, very difficult. I don't know